Hello, math students. Welcome back to Module 11, Geometry. And this is Lesson 20, and it's called Slicing a Right Rectangular Pyramid with a Plane. So in yesterday's lesson, we were talking about slicing rectangular prisms, and in this lesson, we're talking about slicing right rectangular pyramids. Try saying that fast without it being a tongue twister. Okay, so our goal for today. Today we will learn what shape results from slicing a right rectangular pyramid by a plane perpendicular to the base as well as parallel to the base. So we talked about that a little bit yesterday, except the difference was we were working with prisms. Today we're doing pyramids. The question that I want you to think about in this lesson is, does a perpendicular slice always have to be in the middle of the figure? Okay, something to think about. Things to know: a pyramid is a three-dimensional figure that has a base and triangular faces combined at one point. So if you think about a net of a pyramid, depending on what the base is, you have seen nets that look like this before, and when you fold them up and you put them together, what was the 3D figure that was formed? If you're saying pyramid, you're correct, because this point matches up with this point, which matches up with this point, which matches up with this point. So when you fold it, they all combine in that one point, and that's what gives you the pyramid effect, because they're all ending in one point. The number of faces is determined by the type of base that the pyramid sits on, and that's very, very important to know. So this right here is a square pyramid, and what makes it a squared pyramid is because there's 4 sides to the base. So 4 sides to the base is going to result in having 4 triangles that combine at that one point. Rectangular pyramid, same thing. It has 4 sides, but this side of your rectangle is longer than this side, so this triangle has a longer base, whereas this triangle has a shorter base. So that would be a rectangle pyramid. This one is a pentagonal because you have 1, 2, 3, 4, 5. So this is considered a pentagonal pyramid. And this one is a triangular pyramid, 1, 2, 3. And the commonality that they have making them pyramids is that they all combine at that top point. They have a different base, but they all combine at the top point. So all of their nets are going to have the shape of whatever their base is, and then the corresponding sides of the triangular faces will be numbered off by how many sides there are on the actual base. Okay? So, getting back to what our lesson is about today, it isn't just about pyramids, it's talking about slices. So in yesterday's lesson, we talked about slices as being geometrical planes that intersect and cut through 3D figures. So a slice made to pyramids that are parallel to the base are scale drawings of the base with a reduction in scale factor. This is the coolest thing that I have learned about doing this. So I want you to envision this rectangle pyramid right here. If we were to take a plane and slice it in the grayed out area that you see, so this is the plane that, or there was a plane that sliced right through here. If I was to pick up this pyramid, ta-da, and take the top off, what shape do you see? And the answer to that question is a rectangle. And if you look, this base is also a rectangle. So this pyramid is a rectangular pyramid, and the coolest thing, if you think about it, is as you move up the pyramid, the actual surface area of the rectangle that would be there as a result of the slice is getting smaller. So what I want you to think about, when you're making slices that are parallel in a pyramid, the actual shape that results, because that's what we're looking for, is the exact same shape, except it's a reduction. Do you see that? This one's big, this one's small. So if we called this the actual, and then we called this the scale drawing, what could you notice just by looking about these two figures? This one's bigger, this one's smaller. So when you're going from big to small, what is it called? A reduction. So a slice made to pyramids in the parallel fashion give you a result of the exact same shape as the base, the only difference is that it's a reduction. So that's pretty cool, and you need to remember that, because that's a favorite thing for big testing companies to ask kids to see if they can remember that, so that's really important. Okay, slices made to pyramids that are perpendicular to the base are different shapes due to the location of where the slice takes place. So this is a little bit harder to envision, so I want you to really pay attention to what we're looking at. If we have a rectangular pyramid, which we do right here, I want you to envision that this is where the plane entered. It didn't enter at the top, it entered a little bit down from the top, and when it did, it went straight down. Well, as a result of going straight down, if we were to pull this apart, so I take off this whole section right here, I'm going to remove it, right? I lift it off and it's gone. The shape that is left there once I remove this whole piece is what shape? What shape do you see right there? You actually see a trapezoid. So the answer to this question is that the slice is a trapezoid, okay? Whereas the slice up here, the slice is a reduced, because it's a reduction, rectangle. So that's pretty crazy. It's the exact same pyramid. The exact same pyramid. Did you notice that? Exact same pyramid. This is a rectangle pyramid. This is a rectangular pyramid. And yet when you change the location of the slice, you get a completely different shape. So if you put in your plane and you sliced parallel, then your shape is exactly the same as the base, only smaller. Whereas if you put in a plane going perpendicular, you have a completely different shape than the base. The base was a rectangle. This slice is a trapezoid. So that's pretty crazy. Now I want you to take it one step further. Exact same pyramid, rectangular pyramid. I hope you can see it. However, this time the plane entered right at the tip-top point and it went straight down, perpendicular to the base. And look at what shape results because of that. So if I lift off this chunk that we cut off, what shape resulted from a slice that was perpendicular to the base from the point? And the answer is the slice is a triangle. So that's pretty awesome. That means that depending on where the slices start from, that's what will determine the shape of the resulting piece that's left over. Okay, so going back to our goal for today we will learn what shape results from slicing a right rectangular pyramid by a plane perpendicular to the base, as well as parallel to the base. We did that just by looking at those examples on the other side. Does a perpendicular slice always have to be in the middle of the figure? Absolutely not, and we proved that right here. It can be on the outer edge. It could be right at the tip-top middle. Perpendicular always means you're going to be slicing down, however. So depending on where you slice it from, that's how you determine what the slice is shaped like. All right? Okay, kiddos, I can't wait to give you a shot with this. I have a couple of videos that I'm going to show you in class so that you can see some more of it, and we might even get to play with some clay. All right, hope this is fun for you. Talk to you soon. Bye!